Tasmania is the great black hole of human evolution. Not because nothing happened there, but because too much happened there. And the gravity of that story is so strong, it bends everything around it. The genetics, the migration models, the dating debates, and the clean diagrams that paleoanthropologists like to print in textbooks. A black hole is not an empty place. It is a place where light cannot escape. Tasmania is exactly that. We can see the shadow of what it swallowed, but the evidence itself, the most decisive evidence, has slipped beyond reach. The people who could have solved a major part of the modern human story were severed from the mainland, isolated for millennia, then annihilated in historical time before their genomes could be properly recovered. In that sense, Tasmania is not merely an island, it is a missing chapter. To understand why Tasmania is such an intellectual black hole, you have to strip away the modern map. Tasmania looks like an island today because the oceans are high, but for most of the Pleistocene sea levels were dramatically lower. Bass Strait was not a strait, it was a continent-like plain. Tasmania was not the edge of the world. It was the southern extension of a single connected landscape linking southern Victoria, the lowlands where Bass Strait is now, and northern Tasmania. This changes everything. The ancient people who lived in Tasmania were not originally marooned islanders. They were southerners living on a connected landmass, part of a broader population system in Sahul, exchanging genes and culture with the same southern corridor of the mainland. Then came the flood. As glacial ice melted, sea levels rose steadily and at times quickly enough to erase entire worlds within a few human lifetimes. The Bassian Plain drowned, not in a single moment, but in a relentless narrowing of habitable corridors. Campsites disappeared, river networks shifted, coastal zones collapsed inward, and a connected homeland became a fractured archipelago. Human beings do not passively accept a rising ocean. They move. They retreat to stable zones, to wetlands, to food-rich river corridors. This is not speculation. It is how every coastal civilization in history has responded to drowning landscapes. The southern story of Sahul would have been the same. People displaced northward and inland as the lowlands vanished beneath the sea. This is why Victoria becomes so important. If Tasmania is the black hole, Victoria is the event horizon. Southeastern Australia lies exactly where you would expect the last fragments of that drowned world to remain visible, not only because it was repeatedly connected to Tasmania during glacial low stands, but because it would have served as the mainland receiving zone for displaced southern populations during post-glacial sea level rise. The Murray Basin and its wetlands would have acted as a stable lifeboat, absorbing groups pushed out of collapsing coastal plains. That setting, more than almost any other, provides a realistic human mechanism for why an unusual population signature might appear in inland southeastern Australia right at the time when sea levels were rearranging the world. This is where the Kubul Creek skull and others become impossible to ignore. Kubul Creek is not just an extremely robust Australian skull, it is a red warning light in the human record. The skulls associated with Kubul Creek and related southeastern assemblages became famous because they carry a morphology that refuses to sit comfortably inside the neat popular story of modern humans. Thick cranial vault bones, strong brow regions, large faces, and robust cranial architecture appear again and again in descriptions of these individuals. Whether every detail of interpretation stands unchanged across decades of debate is less important than the larger point. Southeastern Australia preserves human remains that look like they are carrying a deeper inheritance than orthodox models want to allow. Mainstream paleoanthropology often tries to make that problem go away. If a fossil looks too robust, it becomes local variation. If cranial thickness seems extreme, it becomes mechanical stress. If facial breadth seems archaic, it becomes diet. Some of these explanations might contribute, but too often they function like paperwork, like bureaucratic labels pasted onto inconvenient evidence. They treat the robust southern pattern as an embarrassment to be managed, rather than as a geographic signal that demands interpretation. A more coherent approach is to stop treating Kubul Creek as a mystery, and instead place it into a landscape narrative that makes human sense. If the Bass Strait world was drowning, and if southern groups were displaced northward into refuge zones, then Kubul Creek can be interpreted not as a bizarre outlier, but as the mainland echo of a submerged homeland. In that framework, the robust southeastern remains become archaeologically legible. They are not simply archaic Australians. They may represent a population pulse, a refugee imprint, an intrusion of a southern genetic structure into the Murray wetlands as sea level rise closed doors behind them. Refugee movements produce discontinuity. They can bring distinctive morphology into new territories. They can create local clusters that later populations dilute. They can even preserve older ancestry signatures precisely because displaced groups are often demographically small and socially cohesive, carrying a strong founder effect. The drowned Bassian plain would have created exactly the demographic conditions where such pulses could occur. Now the story becomes even more explosive when we introduce the archaic dimension. People often use the term southern Denisovans as a shorthand for the archaic ancestry found in Sahul, especially in Papua and Aboriginal Australians. But that term is deeply misleading, and the more you think about it, the more absurd it becomes. Denisovans are named after one cave in Siberia. That cave is simply where we first recovered diagnostic DNA, not the homeland of every archaic lineage that ever contributed ancestry to humans in the southern world. Papua, meanwhile, offers living evidence that archaic ancestry was not a trivial side note in the southern world. Papuans carry the strongest known Denisovan-derived signal. That alone suggests the archaic component is foundational, not decorative. But beyond percentages, there are hints that archaic ancestry persists in ways that do not reduce neatly to admixture charts. And here is the biggest bombshell of all. Tasmania is the missing genome, but Papua is the living evidence that archaic ancestry can persist in profound forms. Papuans carry the strongest known Denisovan-derived signal. That alone already suggests something big. The archaic story is not marginal. It is foundational to Sahul. But more than that, there are hints that archaic ancestry in Papua is not merely a sprinkling of genes. For example, a recent study found centromere-related archaic structures, unusual retention of genomic architecture in some Papuans, pointing toward a deeper reality. Archaic ancestry may survive not only in percentages, but in deep structural forms that reflect ancient lineages. What this means is that Papuans are not simply modern humans with some Denisovan-related ancestry. They are a hybrid population with deep genetic structure. Schier et al. Is one of the most important recent papers on human evolution, because it uses complete phased, long-read Papuan genomes to create the first real global map of archaic structural variants, large insertions, deletions, repeat expansions, and other genome changes that short-read sequencing usually misses. Since Papuans carry the highest amount of archaic ancestry in the world, they are the ideal population to reveal what earlier studies were blind to. Most archaic DNA is not just a few scattered single mutations, but large structural blocks that shape the genome. The most striking finding is just how much previously invisible archaic material survives in Papuans. Because older studies relied mainly on short-read sequencing, the authors argue that over 70% of archaic structural variation was essentially undetectable. With long-read assemblies, they estimate that 4.4% of Papuan genomes are archaic, and that Papuans carry about twice as many introgressed structural variant bases as any other non-African population. In just 4 Papuan haplotypes, they find more than 445 megabases of archaic sequence, showing that archaic ancestry is not a minor side note, it is a major component of Papuan genome architecture. Some Australian Aboriginals even carry unique Neanderthal, a blood type known as partial A positive. Even more unprecedented, the paper reports introgressed archaic centromeres. Centromeres are huge satellite repeat blocks that are normally impossible to study properly. Yet here the authors identify 11 archaic-derived centromeres, especially on chromosomes 4, 11, 17 and 22. Their divergence times, around 400,000 to 700,000 years, match the expected window for the human split from Neanderthal Denisovan lineages. This implies Papuans still carry entire structural pieces of archaic chromosomes, something far beyond what the classic a few percent introgression narrative ever imagined. Finally, the study shows that Papuans carry structural variants from both Neanderthals and Denisovans, but in a surprising pattern. More archaic structural variants appear Neanderthal-derived than Denisovan-derived, even though Papuans are known to carry especially high Denisovan ancestry in single nucleotide variants. This contradicts the simplest models and strongly suggests that the archaic groups contributing to Papuans were not identical to the single Altai-Denisovan genome we currently have. In other words, Denisovans were not one population but a diverse family of branches, and Papuans likely inherited DNA from Denisovan lineages that have not yet been directly sampled in the fossil record. Indeed, genomic evidence already suggests Denisovan ancestry is structured and complex, implying multiple Denisovan-like populations, or at least deep substructure within archaic Asia. So to label Sahul's archaic story as Southern Denisovan risks repeating one of the oldest scientific mistakes, assuming the first discovery defines the entire phenomenon. Calling Sahul-related archaic ancestry Southern Denisovan is like finding archaic skulls in Africa and calling them tropical Neanderthals. It would be ridiculous. Likewise, Sahul likely contained its own archaic population system, perhaps related to Denisovans in a broad sense, perhaps sharing ancestry with Denisovan-like lineages, but possessing its own identity shaped by geography, isolation, and long-term continuity. Denisova Cave does not own that story. It is merely one window into a larger, continent-spanning archaic world. Tasmania intensifies that argument because Tasmania is exactly where you would expect archaic structure to persist. Isolation preserves deep ancestry. Small populations retain ancient components through drift. Island effects amplify distinctiveness. And most crucially, Tasmania's Aboriginal people were devastated before their genomes could be properly sequenced at the scale required to test these hypotheses. That missing data is not a minor inconvenience. It is the central tragedy. We cannot test whether Tasmanians carried higher Denisovan-like ancestry fractions than mainland groups. We cannot test whether they retained unique archaic haplotypes or structural variants. We cannot test whether Tasmania preserved ghost ancestry now extinct elsewhere. In a discipline that claims to prioritize evidence, Tasmania represents a gigantic, gaping absence that should change how confident anyone is about Sahul models. This is what makes Tasmania a black hole, because the absence is not random. The absence is strategically located exactly where the signal would be strongest. If an archaic rich southern refuge existed, then the place most likely to preserve it would have been Tasmania, and the mainland spillover zone, most likely to preserve echoes of it, would have been Victoria and the southeastern corridor. That is precisely where the robust remains become most visible. The geographic logic is too clean to dismiss. Tasmania, Cow Swamp and Kubul Creek was the refuge. Put these together, and you don't get a random scatter of fossils. You get a demographic story. This is the deeper reason paleoanthropologists hesitate to discuss Tasmania in the terms it deserves. It is not just that the evidence is hard, it is that the implications are destabilizing. If Sahul preserves deep archaic structure persisting late into the Holocene, then the clean boundary between modern and archaic collapses into a spectrum. The classification system becomes political rather than biological. It becomes a question of how much archaic inheritance qualifies a population as separate, and where. Tasmania threatens the tree because Tasmania implies missing branches. It implies we have mislabeled populations by forcing them into categories built around African and European frameworks. It implies the southern world is not a footnote to Eurasian history, but a primary arena where archaic human admixture may have shaped modern humans into what they became. In this context, the refugee model becomes not just plausible, but almost inevitable. A drowned world creates human displacement. Displacement creates mixing and discontinuity. Discontinuity creates morphological clusters that later scholars struggle to classify. If the people of the Bassian Corridor in Tasmania carried an older ancestry structure, then their movement north into Victorian wetlands could create exactly the kind of robust signature seen at Kubul Creek. This does not require fantasy. It requires only accepting that sea level rise was not an abstract climate graph, but a direct demographic force that reshaped real human lives and populations. The drowning of Bass Strait was not merely a cartographic event, it was a population event. In the end, Tasmania is the missing chapter not because we lack fossils, but because we lack the genomes that would allow the fossils to speak clearly. Tasmania is the black hole into which one of the most important datasets in human evolution fell. Victoria now holds the last embers of that drowned southern world, and sites like Cow Swamp become the fragments of light escaping from the edge of the abyss. If paleoanthropology wants to be courageous, it must stop treating Tasmania as a marginal curiosity and start treating it as what it is, the one place where the archaic southern story could have been clearest and where its loss may have permanently blinded us to the true depth of Sahul humanity. Thank you for watching.